Hey guys, so we already talked about converting back and forth when something's in radical form and giving it a rational exponent or vice versa, having a rational exponent and converting it to radical because it helped us simplify. So today we're going to look at some questions and work with actual operations, so adding, subtracting, multiplying, and just to simplify those expressions. So our first one, it says, which of the following are equivalent to 7 root 5, 7 square roots of 5? So if we go to our options, again, 14 to the 1/2 times 25 to the 1/2. I cannot do much with that. However, I can rewrite it as a radical because I know that 1/2 power, that 2 is my index, so it becomes the square root of 14 times, same thing, square root of 25. Again, they both have a power of 1, but that doesn't change anything. Well, that's awesome because I know the square root of 25 is 5. Okay, and then 14, let's see, can I break that down? Factors of 2 and 7, both of which are prime numbers, so we can't break that down. So simplified, my coefficient, my whole number is going to come out front, so it's going to be 5 square roots of 14. Definitely not equivalent to 7 root 5. All right, so let's try another one. 49 to the 1/2. Again, I'm going to rewrite, so the square root of 49 times, same thing, square root of 5. Oh, they're making it easy. What's the square root of 49? Well, again, if you don't know off the top of your head, we're going to factor. Well, what times what gives me 49? 7 times 7. So I got a pair of 7s. So 7 square root of 5, and that's what we're looking for. So that one does simplify. It is equivalent. All right, square root of 70. Let's see, square root of 70. That's definitely not prime, so we can definitely break that down. So factors of 70, first one that comes to mind for me, 7 and 10. 10 gives me 2 and 5, and again, square root, I'm looking for pairs. I don't have any groups of 2, so the square root of 70 actually can't be simplified. All right, I guess I'm done. So at any time, if you're like, all right, I'm good at this, I'm comfortable, pause the video and try them on your own, then come back and check. I'm totally okay with that. Whatever makes you comfortable. All right, so square root of 155. Ooh, all right, so definitely 5 goes into it, so 31. 31 is prime, so I'm done again. All right, let's see if any of these will simplify. Square root of 7 times square root of 5. I cannot simplify those. Now they're both square roots. So since they're both square roots, we actually can multiply them to the square root of 35. But again, that's not going to help us because 35 has factors of 5 and 7. No pairs, so that's as much as we can break it down. All right, another one of these has to work at some point. Let's look at the square root of 196 times the square root of 5 divided by 2. Okay, square root of 196. I know that's a perfect square. I'm trying to remember. I've got, let's see, 144, that's 12. Oh, and then we got 169 is 13, 196 is 14. So the square root of 196 is 14. Remember, if you did not remember that, just write off to the side, square root of 196. Start breaking it down and start looking for your pairs. Okay, if you had to break that down, does 3 go into it? I don't think so. So 2 goes into it, 98. And 2 again. 49 and 49 is 7 and 7. So I got a pair of 7s, a pair of 2s. They'd both come out. 2 times 7 would give me a 14. So I've got 14 square roots of 5 divided by 2. Hey, well, what's 14 divided by 2? 7 square roots of 5. So that one works. I knew one of them would have to work. All right, square root of 49 plus square root of 25 divided by 5. This one's different. So square root of 49 plus square root of 25 divided by 5. Well, square root of 49, we know that's 7. Plus the square root of 25 is 5. So 7 and 5, 12 fifths. I don't think there's any way that that's going to turn into 7 root 5. So those are the only two answers that I see. What else did it say? What is key when adding and subtracting expressions? Well, what's key when adding and subtracting expressions? They gotta be like terms. Okay, if I'm gonna add something, I can't add the square root of 5 plus the square root of 7. They have to be like terms. Now, is there anything special about multiplying? That I want to go back to. So square root of 7 plus square root of 5. I cannot add those. They're not like terms. They don't have like bases. However, when it's square root of 7 times square root of 5, as long as they're both the same kind of root, so as long as they're both square roots or both cube roots, those you keep the root and just multiply what's inside. So our radicand. So is there anything special about multiplying and dividing? Well, yeah. They have to have the same root. So same root, same index, whatever makes more sense to you. How can we use exponent rules when simplifying radical and rational exponents? Well, I'm pretty sure when we complete some of these, we're going to find out. So square root of 12 plus square root of 3. That's what I was just talking about. To add them, they have to have the same base, which these don't, the same radicand. So let's go ahead and simplify, because 3 is prime, but 12 is not. So let's see if we can break down 12. So square root of 12, I've got 2 and 6, and 6 gives me 2 and 3. Boom, square root, we got a pair of 2's. So 2 root 3 plus root 3. Well, what I want you to think about is, what's the coefficient here? Here I have 2 roots of 3. How many roots of 3 do I have here? What's the coefficient? Well, we can put in that invisible 1, those invisible maths. So 2 roots of 3 plus 1 root of 3. If you're questioning it, think about it like a variable. 2x plus 1x is what? 3x. So 2 roots of 3 plus 1 roots of 3, that gives us 3 roots of 3. And we're simplified. Cool? All right, let's look at this next one. So 27 to the 1/2, 15 to the 1/2 minus the square root of 18. So these are all in different formats. Well, they got to be the same format before we can simplify. So the easiest way is to take this rational exponent and convert it to a radical. So far, they're kind of being nice to us. They're giving us everything that's an index of 2. So square root of 72 plus the square root of 15 minus the square root of 18. So far, no like terms. All of those radicands are different, so let's go ahead and break these down a little bit, see if we can simplify. So 72, I've got 9 and 8, 9, 3 and 3, 8, 2 and 4, 2 and 2. So again, it's all about the square root, so we're looking for pairs. I've got a pair of 3's, a pair of 2's. Don't forget about that little 2 that's left over. So when they come out front, we're going to multiply. So 3 times 2 gives me 6 roots of 2. All right. What about 15? 15 is just 3 and 5. So that can't be broken down anymore. So it just stays 15. Now what about 18? I bet we can simplify 18. So 18, I've got 2 and 9. And 9 gives me 3 and 3. Awesome, a pair of 3's. So minus 3 roots of 2. Now, let's look and see, can we simplify anymore? Are there any like terms? Well, it's all about that radicand. That's what we want to look at. So I've got 6 roots of 2 minus 3 roots of 2. So since the square root of 2's are the same, we can combine them. So 6 roots of 2 minus 3 roots of 2 leaves me with 3 roots of 2 plus 1 little square root of 15. Cool beans. If you wrote square root of 15 plus 3 roots of 2, that absolutely is equivalent, so it would absolutely be correct. All right, square root of 32 plus cube root of 16. I can't, well, they don't have like bases anyway, but the square root and cube root, that's the kind of waving a red flag for me. So I'm going to go ahead and simplify because I can. So square root of 32 gives me 16 and 2 and 16, 4 and 4. So I got a pair of 4s. Awesome. So we're just, remember, index of 2, so we're just looking for pairs. So I've got 4 roots of 2 plus, now if I break down 16, 2 times 8, 8, 2 and 4, 4, 2 and 2, and we're looking for groups of 3. So I have a group of 3 2's. So plus 2 cube roots of, don't forget about your little leftover, cube roots of 2. Now, can we simplify? Can we combine these? Again, I have a square root of 2 and a cube root of 2. Those are not the same. That would be like adding 4x plus 2y. Can't do it. So we're done. There's nothing else that you can do to simplify this one. Cool? So I would recommend that you go ahead and pause the video and try these next two and then come back when you get your answers. See how you do. All right, guys, you should be back. So let's go ahead and see what you got. So 6 to the 1/2 plus 3 times 6 to the 1/2, just like anything else, order of operations. So I'm doing this chunk first. So 3 times 6 to the 1/2. That 1/2 tells me 3 times the square root of 6. Okay, easy enough. So you can put that dot in there or you don't have to, it's up to you. And then plus the square root of 6. Hey, do we have like terms? Yeah. Remember, how many square roots of 6? So 1 square root of 6 plus 3 square roots of 6, 4 square roots of 6. Cool. All right. This next one, we got a radical, rational exponent, and a radical. So let's go ahead and change that rational exponent to a radical so I have something I can actually work with. So cube root of 2 plus 1/3, so a cube root of 8 plus a cube root of 16. All right, now let's break these down. So cube root of 2, 2 is prime, it's just got 1 and 2, so it can't be broken down anymore. All right, cube root of 8, I know what that is offhand, but in case you don't know it at the top of your head, just factor. So 8 has factors of 2 and 4. 4 has 2 and 2, and we're looking for groups of, you guessed it, 3. Awesome, so nothing left over. So plus 2. So we got a cube root of 2, couldn't do anything with that, so it just comes down. Plus 2. Now let's look at this last one, cube root of 16. I bet something can come out of that radical. So let's see, 2 times 8. Well, if you remember, what's the cube root of 8? 2. But if you didn't, go ahead and keep breaking down. 4 and 2, 2 and 2. So we got a group of 2's. So plus 2, and we got this little lonely guy left out. So 2 cube roots of 2. Now, before you are finished, make sure you look to see are there any like terms? And in fact, I have a cube root of 2 and 2 cube roots of 2. So remember, how many cube roots of 2 is this? 1. So 1 cube root of 2 plus 2 cube roots of 2 gives us 3 cube roots of 2. Plus 2. And there we are. So that was all addition and subtraction. The big thing is like terms. Make sure things are like terms so that you can actually combine them. So now let's look at some multiplication problems and a little division. Now, when multiplying radicals, there's a couple different ways that we can approach solving these. Like many math problems, there's multiple ways. So I could look at this and I say, okay, square root of 10 times square root of 2. So sometimes we'll be like, oh, I just want to simplify it because I'm used to doing that. Well, you can, but if you simplify first, you might have to simplify at the end as well. So I'm going to go ahead, since both of these are square roots, I am allowed to multiply them. So I'm going to keep my square root, multiply the insides, multiply my radicands, and 10 times 2 gives me 20. So now I'm just going to simplify once and I will get my answer. So when I break down 20, factor it, I get 4 times 5. Remember, when I'm doing these, if you think of different factors, that's completely fine. We should all simplify to get the same answer. So square root, pair of 2's, so I'm left with 2 square roots of, and I got a 5 left over. 2 square roots of 5. That's it. So just make sure they're both the same they both have the same index before you simplify. So 2 to the 1/2 times 2 to the 1/3, can't really do much with them, so I need to convert and rewrite them as a radical. So I have the square root of 2 times the cube root of 2. Now, this is where you have to stop and think. Can I multiply these? Are they the same? One is a square root, one is a cube root. They are not the same. You literally can't do anything else. You are done. You cannot simplify. So it was already in simplest form. Just one version is written with rational exponents. The next is written with radicals. So, all right. 10 to the 1/2 divided by 2 to the 1/2. So I'm going to rewrite this as a square root of 10 divided by a square root of 2. You could leave it like that. Since they're both square roots, you can divide them. If you want it a different visual, you could rewrite it with one big radical and 10 divided by 2. So what's 10 divided by 2? Square root of 5. And 5 is prime, so I can't simplify that radical anymore. We're done. All right, I hope those were some good examples for you guys. Let me know if you have any questions. Have an awesome day.